Hi all. So in the last session, we have discussed about what are the concepts we are going to learn in this particular course. And in today's sessions, we'll actually dive into the concept of data structures. So the first topic is introduction to data structures. Yeah. So now, first, we will see deeply what is actually meant by the data structure. So in the image, you can see that there are many different, that is actually the structures in which how we can store or arrange the data. Okay. So each type of arrangement, what you can see there is nothing but the different types of data structures we are having, nothing but how we are going to arrange the data inside the memory so that you can perform some operations on that data in an efficient manner. And when we are performing the operations on the data, when we are actually solving a problem, okay, a complex problem needs a solution. Okay, so when it needs a solution, the solution will lie in what type of data you're going to use and how you're going to implement it and what data you're going to use. So that's where the solution lies, and that is why you need to know about the data structure, about the algorithm, and some other more things which is coming to that. Okay. So now we'll see this concept. Data structure, it is a branch of computer science. Okay. It's like in a science, we have many different other branches like biology, zoology, all those things. Okay, if I take the biology as example, there are many multiple branches. In the same way, in computer science, one of the branch is data structures. Okay, so the study of data structure allows us to understand the organization of data and the management of the data flow in order to increase the efficiency of any process or program. So as I've explained you, it is nothing but you're learning about or you're understanding the different way in which I can organize the data. Why you need to organize the data so that you can manage it properly. And also, what it will do is it will increase the efficiency. So, as I told you, if there is a problem, you need a solution. How you are finding the solution? You are finding nothing but for a particular solution to be solved efficiently, solving the first case. Okay, but how efficiently you're solving is matters very much. So how to solve it while solving it, which makes more efficient, which solution makes more efficient while you solve something or some problem. Data structure plays a very important role there. Okay. So data structure is a particular way of storing and organizing the data in the memory of the computer so that these data can easily be retrieved and efficiently utilized in the future when required. Okay, so like we are storing and organizing the data in the memory of the computer. Okay, that is nothing but the data structure, and why we need to do that, which can be easily retrieved and efficiently utilized in the future when required. So the data can be managed in various ways, like the logical or mathematical model for a specific organization of data is known as a data structure. Okay. Now, to put it simply, if we actually want to know what is the data structure, if someone asks for a definition, it is nothing but it is a storage. Okay, it's just a storage, and what we're doing there is we are using to store and organize the data. How we are storing the data, let me verify, just store it randomly. Okay, for example, we have books. Okay, in a random way, I'll just dump it here and there. What will happen? What book, if I have many categories of books, okay, suppose we'll take the example of library. I have there are many departments and there are many books. If I didn't organize, I will be storing all those books in one place, which is library. But now there in the library, when I went, I wanted to find one book, but I'm not being able to find it because they are not organized properly. So if the data or if the book is not organized properly according to anything, like whether it can be genre, whether it can be language. Okay, so that's how similarly the data structure is working. So if the things are organized in such a way, okay, if for example in the library I can get newspapers also. So the newspapers, should they hid it somewhere in the corner of the library which takes me too long to reach there? No. Newspaper is something you change it daily. Okay. So when you enter itself, you need to be getting it. So the access need to be very easy. Okay. So that's how, and that is the same role played by the data structures. We have different data structures for different problems. Okay. So why we need data structure? So that it is a way of arrangement in the computer so that it can be accessed and updated efficiently. We are storing the data. Okay. We're arranging the data on the computer. So why we need to access it and update it efficiently? Okay. The time, in terms of time, in terms of space, everything need to be thought about when you are arranging a data properly. Okay. That is nothing but data structure. So a choice of good data structure makes it possible to perform a variety of critical operations effectively. Okay, even if there are some critical operations, okay, but if you wanted to make it in a very simple way, or you wanted to make it effectively and efficiently, you want to get the output after doing the operations, nothing but we need to have a good choice of data structures. Why we need to have that? Because different problems will be having different uh, ways in which I can solve them, correct? Okay. So, an efficient data structure also uses minimum memory space and execution time to process the structure. Got it? So, everything lies with the data structure. Now, if I say, uh, do data structure play a very important role in everything what we see in the IT field now? Yes, of course, because always we think what we want everything to be happening in a split second of time, and also the storage is very much important. Okay, how much, like if I want to execute something, the things needs to be executed in a minimum memory space. That needs to be our main motto. Okay, when we are developing something, it shouldn't take much MB of or space of your systems. Okay, like for example, even if we'll take the examples of users, us only. Okay, like if you actually want to install some games. Okay, there are some games which is available, which can be installed in a mobile phone, which is running with the minimum memory space. Some games need more RAM power, okay, more processor power. Many games are there which you cannot download and play in the mobile phones, which will get stuck. Why? Because the data reading and writing is happening. It's not happening so fast because your processor, first of all, your processor is not working. That is a first case. But secondly, what will happen is that algorithm is not written so that it will be running in your mobile phone or in your specification what you're having. Okay, so most of the time, like gaming, we will keep it in a side. But if I consider some other applications also, like most of the time we are going for a competition and all, like hackathons. So what will happen there is, if you're working with any softwares or hardwares, what happens is always they will be evaluating you with, like, with the minimums per second of time, what which is executing faster, which is giving you the output faster and accurately, which is giving you. That is the first thing. Second thing is the time. Third thing is memory. Okay, how much memory it takes to run. So efficient data structure is nothing but you need to understand the problem first. For the problem, in which way you can solve the problem. So in that way, or which data structures helps in order to achieve that way, is very much important. A data structure is not only used for organizing the data. Okay, now one more thing is it's not only used for organizing the data. As I've told you, organization of things are very important as data is also need to be organized. But in data structure, we are having more than organizing the data, which is it is also used for processing, retrieving, and storing the data, which I call it as operation of operations which we can perform on the data structure. There are many operations which we'll be going through in the end of this session. So, not only for the organizing the data, we are using the data structure, but also for the processing, retrieving, and storing data. Now, there are different basic and advanced types of data structures that are used in almost every program or software system that has been developed. Okay, you can have basic data structures also, advanced data structures also. So this we have seen which are the basic and which are the advanced type of data structures when I have just gone through with the introductory class. Okay, so because of all problems, we must have the good knowledge of data structures. So if you are good in data structures, you will become a good developer, you will be able to develop a better system which is working with the limited space. So next, okay, now we have understood what exactly a data structure is, what you can do with it, but now we'll see why we need the data structure. So as the applications are becoming more complex and the amount of data is increasing every day, which may lead to problems with data searching, processing speed, multiple request handling, and many more. Okay, these are the things what we are actually facing. So as I told you, if you keep your books in the library in an unorganized way, what will happen? You may not be able to find a thing whenever you just want it to be okay in your hand within a split second of time. But what is the case if it is organized properly? You directly go to that particular section and you take the book and you come. Okay. So when the data are increasing, if they are not kept in a proper way or the proper method, if they are not handled properly, then the data searching would be difficult, processing the speed would be difficult, the processing speed will be very less. Sorry, uh, speed is not a very good thing because it is going to be very slow, right? Because you keep on searching the data, so the processing speed is very low because you're not being able to get the data. How will you process it? Okay, so that's the case. Now data structures support different methods, okay, to organize, manage, and store data efficiently. So with the help of data structures, we can easily traverse the data items. Means many different data structures will have their own way in which how you can traverse the data items. And data structures provides the efficiency, reusability, and abstraction. Okay. Okay. Now, one more thing is like why we should learn data structures. We understood the need for the data structure, why we need to learn data structures. So I have explained this more often. Okay, but we can go through this concept. Data structures and algorithms are the two key aspects of the computer science. Okay, and we know, absolutely we know it because everything is working to make it work, we have to do something. Okay, we have to write some codes that includes some algorithms. Without that, it is can't. And data structures and algorithms go hand in hand. They will be together. What data structure you are using, so depending upon that, you will be using some algorithms. So data structures allow us to organize and store the data, whereas algorithms allow us to process the data meaningfully. Got it? The processing, everything is happening with the algorithms because they are the ones who will be directing what to do and how to do. Okay, but how we are storing the data, whatever data you are getting, the organization will be done by the data structure. So they are in this way they are related to each other. Now, learning data structures and algorithms will help us become better programmers. As I've told you, if you know data structures, you will become a good developer because in DSA, data structures and algorithm, what we also learn is not only what are the different data structures available, or not only what are the different algorithms available to work on it efficiently, but also we'll be learning how to check whether an algorithm developed is proper or not in the proper as I told you, if you develop something, it needs to be running in the processing time needs to be very high, means it should take a minimum time to run something and also to give the output. And also we need less space taken. Okay, the less space need to be taken for um, storing purpose. Okay, the storage with less memory, it has to perform high, and it must be efficient, and also it needs to be accurate. Okay, so okay, after learning this, what will happen? We'll be able to write the code that is more effective and reliable, and also we'll be able to solve the problems more quickly and efficiently. Got it? So yeah, that's what we will be analyzing how a written algorithm will be efficient for a particular data structure. So that is by using two things: the complexity analysis. Okay. Okay. Now we'll see some of the objectives of the data structures. Now, that means why the data structure is there. What is the main objective? Oh, because of what reason we will be having, we need to have data structures. So, first thing is correctness. Okay, the data structures are designed to operate correctly for all kinds of the inputs based on the domain of the interest. Domain of the interest means it's up to you, like for what problem you're going to solve. For if it is a healthcare issues or if it is some other thing. Because there are many domains, correct? So to which domain you are actually solving the problem? Healthcare, education, then what else is there? Banking sector, finance. There are many things. So it's for all those inputs, whatever for all the kinds of inputs, whatever you give, the data structures need to be working properly. Okay, in other words, the correctness forms the primary objective of data structure, which always depends upon the problems that the data structure is meant to solve. Second one is efficiency. So the data structures also requires to be very efficient. Okay, it should process the data without utilizing any computer resources like memory space, as I've told you. And in a real time, the efficiency of a data structure is a key factor in determining the success and failure of a process. So, whatever you develop, it needs to be very efficient. If it's something like you want to throw it tomorrow, but what is the use of creating that particular thing? So, we need to be very careful when we are developing something. Okay, so because it should be a long run process. We are using many applications which is running over decades, correct? Okay, there are many applications. If I say you are using YouTube, okay, which came across 2008, 9, and some years. Okay, now 2019 has passed. Now we are in 2025. This has been running for decades, and how how this has become. Okay, so just give me a second. So that's the main objective of data structure. And next is understanding some key features of the data structures. Okay, so first thing is the robustness. Okay, so what robustness means, we know that all the programs is aim is to produce the software which is yielding the correct output. Okay, so for every possible input, along with the efficient execution on all hardware platforms. Yeah. So I was talking about the YouTube thing, right? So in YouTube, what happens? So since even if they have built it in that era, okay, it is still running. Why? Because they have been keeping updating on it. It would be very difficult if they have not chosen the proper data structures when they were creating the app in that time. Now in my system, which is very high level, it is still working, correct? Okay. So, but after updating with some machines, it's not being executing because that machines are not supporting after the updates. That's one thing. Okay, but that's what when we develop something, when we want to develop something, we have to always aim towards the long run. Okay, for the long running thing, we have to.
Excuse me, ma'am. मैम मुझे मतलब एक डाउट था मतलब मैम
Okay, yeah. Okay, so that's why what the view of every programmers need to be in the long run. Okay, and okay, so we all aim to do what? Always we need some correct output for every possible input. That's why we have a separate section as a tester. Okay, I mean you work as a software tester, right? Because we aim for like for all the outputs. Okay, we for every possible input output properly, the correct output, and the possibility of the input can be in a very different way. So the first thing what the feature of the data structure is, it's robustness, and the second one is adaptability. Okay, so what's there? Building the software applications like web browsers, word processors, and internet search engine includes huge software systems that require correct and efficient working or execution for many years. As I've told you, we have to always look for the long run. So adaptability is nothing but even now for my mission, it is working properly because at that time, whichever has been here using now, still I remember the web browsers like Internet Explorer and Firefox. Okay, everything is still running. Okay, we are using it still. Why? Because at the time of the initial version, they have made it in such a structure that it supports for everything. Okay, moreover, the software evolves due to emerging technologies or ever-changing market conditions. So we keep on updating the things because the users, the market may want for some advanced thing. Day by day, they will have many more. Like for example, if I consider WhatsApp only, how many new features are there? Or if I consider the YouTube only, how many new features we have been seeing from so many years? What has been added? New features being added. Okay, it's many years. Okay, we are the users of it. Okay, we are the regular users of it, and we can see many changes in it. That's nothing but the what market is asking for it. Okay, so what what conclusion on this is, so whenever we choose a data structure for a particular things to be done or for a particular development of a software or anything, we always need to think about the future. So in future, if something happens, so how you're going to handle it? So you have to keep an extra place for it, and everything you need to manage at the time when you are actually planning to build something extraordinary. Okay. And the third one is the reusability. So the features like this reusability and adaptability go hand in hand. So it is known that the programmer needs many resources to build any software, making it a costly enterprise. So it's not an easy task. Even if you want to build a software, it is not an easy task because, see, for example, if I want to host a website, whatever I have created, I have developed a website, and I want to make it available to the users. Okay, when you type www dot, you want it to be globally available for the users. So it actually costs you. So for the hosting, you have to pay, you have to buy the domain, you have to buy the hosting, you have to pay for it. Okay. So it will be like your yearly plan. Okay. So 3 years, 5 years plan. So it goes on like that. So when you build a software, it's actually a costly enterprise. Okay, but the software is developed in a reusable and adaptable way, then it can be applied in the most future applications. So one software you are developing, and that can be reusable and it can be adaptable for the long run. Okay, uh, which can be executed for many years without any problem. So then again, by executing the quality data structures, it is possible to build the reusable software, which appears to be the cost effective and time saving. All right. So instead of, if we know we can reuse something, so um, instead of rebuilding it, building a software costs you, okay, cost you the fortune, but then again, uh, rebuilding it would cost you the double. So if it can be reusable, then it is cost effective and also time saving. You don't have to build the same thing what you have built out. Okay. So now let's see about the classification of data structures. So now here you will see some of the names, okay, which is actually the data structure, what we are going to learn in this entire course. Not only data structure, we'll be also learning about the algorithms and some other concepts. Okay. So we can classify the data structures into two categories. One is primitive data structure and another one is non-primitive data structure. So to put it simply, I hope you all know programming languages and all, correct? You might have seen something which is shown here as primitive, like int, char, bool, and float. So these are nothing but what we studied as the primitive data types, correct? But these data types which are primitive is also called as a primitive data structure. What do you mean by data structure? We are storing and organizing the data in such a way, correct? But this can also be considered. This basic data types can also be considered as structure. And that's a primitive data structure. And one more is the non-primitive data structure, which is like um, these data structures will contain the data which is of these types. That is why they are non-primitive data structures. Okay. And when we learn about the data types also, we'll be seeing that like primitive data type and non-primitive data type or derived data type. In the same way here. Now, when I consider the non-primitive, there are two things. One is linear and one is non-linear, which means we are storing the things in linear way and we are storing the things in non-linear way. Okay, we'll come to know it in deeper. Okay, in the next slide. So in linear, there are two types. If I further divide it, they are static and dynamic. Okay, and in static we have array. Okay, and dynamic we have linked list, stack, and queues. Okay, then in nonlinear we have tree and graphs. We'll see one by one. Actually, if I take the concept of array, there is much more thing to explain. It's not like I can end up in today's class because if I take one data structure array, okay, there are many things, many concepts to be learned in that, and different types of arrays are also there. Same goes for the linked list, same goes for the stack, and same goes for the queue. Okay, so there are many things, the operations, all those things. But in today's class, we'll be just seeing about the introduction of data structure. What is it? Why we need it? How we can classify the data structures? Which are the different data structure? And then what to say? Like where you can apply. Okay, in which stream and all we actually need the data structures, or how they make our work efficient if we use data structures properly. Okay, however, to build something, we have to use data structures, but using it very properly according to the problem statement is very important. So the main two categories is primitive and non-primitive. Okay, now if I come to the primitive data structures, they are the data structures consisting of the numbers and the characters that come inbuilt into the programs. We know that in whichever language you write the program, some these primitive data structures, we call it as the built-in data types. So these data structures can be manipulated or operated directly by the machine level instructions. Okay. So the basic data types like integer, float, character, and boolean come under the primitive data structures. And then these data types are also called as simple data types, as I've told you, as they contain characters that can't be divided further. So the primitive data structures, the main thing is which can be manipulated or operated directly by the machine level instructions. Okay. But non-primitive data structures are not like that. With the machine level instructions, we cannot do anything. Okay. So we need something else for that. That is why we are using the help of algorithm in it. So non-primitive data structures are those data structures derived from the primitive data. As I told you, in our primitive data types, if I consider integer numbers can be stored in the form of array. Now, array is nothing but our user-defined, sorry, not user-defined, it is a derived data type, correct? Okay, so which is derived from which one? Some integers. Okay, this means it is an array of integers, so it can be derived from the integers. So these data structures can't be manipulated or operated directly by the machine level instructions. Now, this is the main difference between primitive and or non-primitive data structures. So the focus of these data structures is on forming a set of data elements that is either homogeneous or heterogeneous. So, means the data structures, what we are focusing here is on forming a set of data elements which can be homogeneous, means all the data, the group of data elements what we are storing in a structure is homogeneous. Either it is all of the same data type or that those are of different data types. So based on the structure and arrangement of the data, now in the classification of data structure, we have two, primitive and non-primitive. Now, for the non-primitive, if I come, we know that data structure means how we arrange them. Okay, the arrangement of data, the organization of the data. So depending how you arrange the data, we have two categories. One is linear and another one is non-linear. So now, since I've told you the categorization is based on the arrangement of data, the naming is given linear and non-linear. So what is linear? We can consider it as the data is arranged in a linear way, one after the another, like in a straight line. So what is non-linear? It is not in a straight line. So it is in some other order. Okay. So that's how the two categories, two subcategories is coming under the non-linear data structure. I mean, non-primitive data structure. So let's just see what is linear data structures. Okay. A data structure that preserves a linear connection among its data elements is known as linear data structure. Okay, the connection between them will be linear. Okay, the one after the another, each element will be. So the arrangement of the data is done linearly and where each element consists of the successors and predecessors except the first and the last data element. Means here the connection between all the elements will be like if I'm the element, my left and right side also will have the elements. Okay, that is the connection. And if I want to get, if I am the second element and if I want to get the fifth element, there are some other elements in between. Okay, so in that data, okay, there is the linear connection. So the successors and predecessors will be there except for the first and the last one. And based on the memory allocation, now in the linear data structures itself, they will be stored one after the another. Okay, one after the another in the sense, like they will be having the linear connection. So apart from that, based on the memory allocation, again, the linear data structures can be divided into two, which is static data structures and dynamic data structures. Okay. Now, what does the meaning static means? It is not changing, correct? It's like it's static. Dynamic means it keeps on changing. So now let's see what exactly here it is: static data structures and dynamic data structures. So in the linear data structure, first category is static data structure. So the data structures having a fixed size are known as static data structure. That means below it is given the array is the best example for the static data structure. Means um, we have used array. If you have gone through the programming languages or if you have gone through the tutorials of Java and all, we have seen array which is being once if we create, no, we cannot. If you have created the array with the size of 5, you cannot add the sixth element, okay, because its data can be its size you cannot edit it, okay. Once you fix it, it is fixed, but its data you can modify it. It's not an issue, okay. That is why we consider it as a static data structure, okay. Array is considered as a static data structure, okay. uh, tree is not a linear data structure because, okay, I'll come to it, okay. So okay, I'll explain it here only. Like for example, this is how the array is stored, okay. And how the tree looks like. Your normal tree will look like this, right? Okay, a conical shape. So in trees, the things are coming like this. So are they placed one by one in a straight line? No. Okay. So the trees are not a linear data structure. They comes in the part of non-linear data structure. Okay. Okay. So the memory for these data structures is allocated at the compiler time and their size cannot be changed by the user after being compiled. So the data stored in them can be altered. Okay. If you have used array concept, then we know that obviously, because once if you declare an array with a particular size, then uh, you can add or delete. I mean, you can modify the elements. You cannot add it extra, but you can delete it. Okay, that's how the array is. Okay, so we will be learning the operations which can be performed on these what data structures. Okay, in detail you will be learning by taking each and every data structures individually, their operations, everything we are going to learn. Okay, so uh, you can go through the two previous sessions which has been already done. In that some briefing is given, like what exactly is linear data structure, what are the different things are coming there, all those things are given. If you haven't, then no issues, we will be covering it in the further sessions, okay. Yeah. So in linear data structure itself, according to the memory allocation, how when it is allocated. So in the static, it is static because we are allocating there in the compile time. Okay, but in the dynamic, we are allocating the what memory at the time of runtime. Okay, so because of that, their size varies during the runtime of the code. The data structures having a dynamic size are known as dynamic data structures. The memory of these data structures is allocated at the runtime and their size varies during the runtime of the code. So the two difference, one is dynamic, one is static. So in the static, the memory allocation is done on the at the time of compile time. That is why it cannot be changed. But when if it is allocated at the runtime, then we can change it. Like once if I create with a particular size, I can go on adding the things, I can go on deleting the things, I can modify, anything can be done. So that is why we call it as dynamic data structures, means those data structures dynamically change. Moreover, the user can change the size as well as the data elements stored in these data structures at the runtime of the code. So, which are the common examples of dynamic data structures? We have seen in the diagram of classification of data structures there, this linked list, stacks, and queues, all these comes under your dynamic data structure. But these things are the linear data structure. Okay, the relationship between one element to another element is linear. Okay. So these are the different types of data structures, linear data structures. So now if you see this diagrams, we can make out, okay, now which is the array in this? This first one is the array. Okay, so these are the array elements. How it is stored? It is stored one by one. It is stored in the linear. See their structure. It forms a straight line, correct? That's why we put this arrays under the linear data structure. And if you see the linked list there, yes, again, this is the linked list. Okay, so this linked list is also having the same thing. One after the another, they are linearly stored. Now, if I come to the stacks, this is stacks. Okay, the name stack is coming from like if I say I'm stacking the chairs, I'm stacking the plates, how they will be placed one top of the another, correct? In the same way, here in the stack data structure, the data are stored one on top of the another. Okay, so this is how the structure will look like. This is the stacks, and here on top of the another, again they are showing the behavior as linear itself. And here we have queues. This is the queue. Okay, queue is similar to what queue we are having in the normal English. So if you want to book a ticket, you stand in a queue. If you want to what else is there for queue? Yes, anything. If you want to do something, we will be standing in a queue, right? How queue is working? Those who are going first will be getting the what service first. So in the same way, those who are coming in the last will be getting the service in the last. Okay, so based on the real life queue, what we are having, these queues are working. So this that is why these data structures are there. Okay, because to solve a problem in a ticket booking, what in a book ticket reservation or in those kind of problems, right? When you develop a software, we use this kind of data structures, which is suitable to solve that problem. Okay, now if I book a ticket, I should be the first one to get the ticket, right? Because I'm the one who is clicking the book ticket button first. So I'll be put in a queue. Okay, so this is how the things will be there. Okay. And if I say about the queue, there are many types of queue. Okay, those also will be learning in depth. Okay, so next thing is the nonlinear data structures. In the nonlinear data structures, what happens? The data element not arranged in the sequential order, like one by one. Okay, now earlier we have seen that there is one linear line, one straight line is there. Okay, for the arrangement, how the elements are stored there. But for the nonlinear data structures, it won't be there. So the insertion and removal of the data are not feasible in the linear manner. Okay, one after the another. Now, for example, in the queue here, so array, it's like I can remove it by index values. Okay, and if I say the queue, the first one, the first person will be the one who is going out first. So that's how the removal will happen. Insert how will happen from the back, correct? The queue will go on increasing. Where is it? From the front. If someone adds some element in middle of the queue, what will happen? If someone enters into the queue where you are standing in the middle, what happens? The fight will start, right? So the queue shouldn't work like that. The queue is like whoever comes first will be going out first. Who wants to join the queue should join in the last. So each and every data structures have their own ways of insertion and deletion. Okay. Yeah. So here also in the nonlinear data structures, we are having the insertion and removal not in the way of linear manner. They are separate. So there exists a hierarchical relationship between the individual data items. So if you see the diagram here, the trees and graphs are the main example of nonlinear data structures. Okay. There are others also. If I consider a table, tables are also not the non-linear. They are not in the straight line. They are tabular form. Correct. Okay. Now this example, this one is this is actually how the tree will be, and this is actually how the graphs will be. Okay. Now in tree, what happens is there will be a proper hierarchical level, but not in the graph. In the graph, it's not like that. The nodes are scattered and some edges are connecting them. But in the tree, if you see, there will be a main person in the level zero. There are two persons in the level one, and there are two each in the level two, and the three. in the level 3 there is some nodes, the level 4 there is some nodes. So that is how a tree will look like. Okay, now to say it simply, the first element I can call it as a root, but in graph there is no something called as root there, that is actually different there. Okay, okay, and then we have this, we call it as the siblings of this particular parent. Okay, this one single node I can call it as a child because it is coming from a parent, and this entire 3 nodes together I call it as a subtree because this is entirely called as one tree. Within a tree, this much is called, this much can be called as a subtree. Okay, so these concepts regarding the tree we'll be learning as an introduction to tree in the separate section. Okay, now this is just, we are seeing what are nonlinear data structures and linear data structures, which data structures fall into these categories. Okay, so this we will see in the next class. Okay, so today we have learned about, or else I'll complete it. Okay, so these trees, now if I say tree, a tree will look like this, but there are different kind of trees. One can be called as binary tree, binary search tree, depending upon why they are used and how they are used. Okay, we have AVL tree, we have B tree, we have something called as trie, TRIE. Okay, so there are many things which we will learn. And now these are the different types of graphs. Okay, if you are a math student, okay, you may know it. There are many different types of graphs out there. So depending upon the position of the vertices and edges, the graphs can be classified into different types. These are the 20 different types of graphs what we are having, depending on how much vertices are there, how they are connected by the edges, whether they're not connected by edges, like that. Okay, so we have null graph, trivial graph, then simple graph, multi-graph, pseudo-graph, non-directed graph, directed graph, connected graph, disconnect graph, regular graph. Then we have complete graph, cyclic graph, acyclic graph, which is not having cycle, we call it as a cyclic graph. Then finite graph, infinite graph, bipartite graph, planar graph, Euler graph, and Hamiltonian graph. So these are the different types of graphs, but what we will be learning is how we are going to implement the graph structure in terms of the programs. Okay, and what operations I can perform on it. So there are so many things what we have to learn. Yeah, so this is nothing but for a particular data structures, what kind of operations can be done on them. So this I'll be doing it in the next class. Okay, yeah, so in today's session we learned about, we just gave the introduction to data structure, what is data structure, why we need it, and what happens if we use it. Okay, why we have to use it. Then we have seen the classification of data structures. Okay, what are the different type of data structures and how they are classified. First we classify them based on the primitive and non-primitive data structures. Then if I say non-primitive, there are two, linear and non-linear. In linear we have static and dynamic, which arrays will be coming under the static because it is fixed, and others are coming as a dynamic. And then we have a nonlinear data structure. All those linked list tracks and queues are coming under nonlinear. Linear with the dynamic, but nonlinear is nothing but trees and graphs, which is not a linear structure, which is not having the linear structure. Okay, so that's all for today. Thank you. So if you have any doubts, you can clarify.
Ma'am, hello, ma'am.